Welcome to JavaScript webinar. So today's topic is Dojo Advanced. So today is the last topic that we are going to cover Dojo, and we have actually one more topic that I wanted to cover, which is Dojo Toolkit Utilities and Tools. But since we don't have time for this, we will not cover this topic in this session. And from tomorrow, we're going to actually spend time learning jQuery. So we're going to have a jQuery Basics 1 and jQuery Basics 2. And I'm actually thinking about doing jQuery plugin development. So we might in fact skip CSS and then do the jQuery plugin development. I'm still in the process of creating content, so depending on my progress, we might actually do jQuery plugin development instead of CSS. Okay, so let's move on to the presentation. So Dojo Advanced. So here we are going to actually cover 4 topics: a module system, and oh, sorry, okay, hold a second. You're not seeing the PDF file. Oh, I'm so sorry. Yeah. Okay, so you should be able to see the PDF file right now, right? Okay, sorry about that. So we're going to cover these 4 topics: module system, and AMD modules, and object-oriented programming API support, and HTML5 support, and especially object store API that was introduced as part of the Dojo 1.6 and 7. So let's move on to Dojo module system. So what is a module and what is a package? You can think of Dojo module as a JavaScript file that contains functions that are part of that particular JavaScript object. Okay? So module is basically representing a JavaScript object that contains some functions, meaning methods. And at the most fundamental level, by the way, packages are simply collection of modules. So if you actually hear Dojo or Digit or Dojo X, these are all examples of packages, meaning they are collections of JavaScript files, .js files. So unlike a simple collection of modules in a directory, however, packages actually has some extra features. But for now, easiest way to understand packages is that a collection of modules. Message from Vishal. I'm not seeing the presentation. You should be able to see the presentation. Can people see the presentation okay, and also hear me okay as well? All right, good. So you can see and hear me okay. So that's good. Moving forward. So package configuration. So you're going to actually specify your package configuration as part of your Dojo config. So you specify name and location. The location basically specify the directory where you are going to have your module. And then you specify your main, module. So name is the name of the package, location is again directory where you are going to have your module file, and main is basically an optional parameter that defaults to main, but it's actually used to discover the correct module to load if someone tried to require the package itself. So as a default it's going to be main, but if you want to have a different the name, then you can so typically you're going to have the name and this one at this, the same. Dojo module format. So in Dojo 1.6 and the below, you typically use dojo.provide. This is also supported in Dojo 7, but Dojo 1.7 now introduces modules that are AMD format. So we'll take a look at what AMD format look like in the following slide. So this is the legacy Dojo module. So again, we're talking about 1.6 and below. So in this case, each JavaScript source file must have at least one Dojo provide. So this is basically defining your module in 1.6 and below. And so suppose if you have Dojo foo.js module on the JS Dojo directory, then the foo.js file has to have dojo.provide and the name of the module like this. Okay, before any calls to Dojo requires are made, meaning it has to be the top line. So this is an example. So here we are defining my module, And here this is an example of using another module. Okay, so this module is using my module is using this module. Okay, but before it specify any module it wants to use, it has to specify the name of its own module, my module, and then you can actually specify the name. Okay. All right, so moving forward. Question from no one. The base URL is set to JS. Where is the actual location? So it's basically representing directory structure. So why don't you actually do the hands-on lab? Actually, let's talk about the AMD modules first, and then we'll do our first hands-on lab in which we can actually define our own module in the form of AMD module format. So AMD module format is introduced in Dojo 1.7, and basically AMD module will actually replace Dojo provide and Dojo require if. So these are the old legacy APIs that you might have to use for defining and using the Dojo module. So AMD, as we talked about before, has a various set of benefits. It's fully asynchronous operation, meaning the modules could be actually loaded asynchronously, and true package portability, which means that AMD module can be actually used in different JavaScript environment, for example, like a Node.js. And better dependency management and improved debugging support, and can be used with any other AMD compliant loader and library. So this is actually something compatible with this. Okay, so you can use AMD module in other the loader and the library. So module identification. So basically in the 1.6, you specify your modules in the form of dot notation. So you say my.module.id. However, in 1.7, you're going to actually use the the directory path notation using slash. Okay, so this is preferred format in 1.7. This is still supported, but this is a preferred the notation in 1.7. So these identifiers are used to map directly to JavaScript files. So this notation is reflecting directory structure one-to-one, just like a Java. So when you have a my/module./id, that means there is a my directory. Underneath, you will have a module directory. Underneath, you will have id.js file. Okay. And by taking this path notation, you can also use relative path fragments like this, like a dot or dot dot. Okay, so you can actually make a reference to other modules based on your relative path. So AMD loader has two global functions. Okay, so these are the functions that you can use in your code. So these two built-in global functions are require and define. And of course, we have seen examples of require in many examples that we have seen so far, right? So this is used to load one or more modules. Define is used to define a module. So we have not actually seen examples of define yet because we have not defined our own modules yet. Okay, so mostly we have seen this require global function being used to use other modules. Now, both of these global functions take two arguments. So again, the format of require is very similar to format of define in the sense that they take a list of module IDs that must be loaded, and then callback function that gets executed once these dependencies modules have been loaded. Okay, so the way that you are going to see the way you are going to see both these the global functions are pretty much the same format. So let's see examples of this. So this is an example of defining our own module. So let's say you have the my_module.js file under my modules directory. Okay, so the the location of this file is this. Okay, now I'm defining my module. Okay. And so basically here, you're going to specify all the modules that you need to use in defining your modules. So these are dependency modules. and then you call function, callback function, and taking these dependencies as a parameter. So you can see these are exactly the same format that you have seen when you are using another module using require, right? Okay. And then you are going to return JavaScript object that contains methods. So here it contains 3 methods: set text method, change background method, and restore text method. Okay. So this JavaScript object represent your module. Okay. All right. So moving forward. Question from Kumar. So when the question is it Microsoft / or Unix /? So, the question Kumar was asking is this notation. Regardless of what operating system you're using, you're going to use a /. Okay. All right, moving forward. Now, this is a usage. Again, we have seen examples of using require so far many times. So basically, you're using many modules, and several modules whenever you are actually writing your Java, the Dojo code, right? So you probably have seen require. So this is the case that we are using our own module that we have defined here. So this is the module that we have defined, my module.js file. Okay. So here you're gonna specify your package. So here we have only one module. So the name is my modules, location is my modules directory, and then the main is my module. Okay. So here I want to use my module. So you're going to say require, and then you specify your module. So this is the name of the module, and this is basically the main part. Okay. And then you're going to take it as my module as an argument, and then you can use the methods of your module. So you are invoking like a set text method or restore text method or change background method. Okay. All right, so that's relatively straightforward. So, 2 global functions we just learned of AMD loader was require and define. Again, you are mostly using require because you're using modules created by someone else. But if you want to define your own module, then you are using define global functions. Global function. All right, so this is our first hands-on lab. Okay. So this is the module. So we have defined 2 modules. Okay. So my module.js file and your module.js file. So we are defining 2 modules in 2 different directories. So let's take a look at my module.js file. So we use define global function of AMD loader, and the only module that we are using in this module is Dojo DOM, and we are taking it as an argument. Okay, and then we define 2 methods for this module JavaScript object. One is set text method, and the other one is a restore text method. So set text method is basically taking ID, some element, and the text. And we are basically, putting the text into inner HTML of that ID that we just got. Okay. Restore text is basically, restoring the text to the old value. Okay. So basically, what we have done is we save it into old text, and then we are actually, so restore text, we are restoring the old text. Okay. So this is my module.js file. And then we define another module called the your module.js file. So again, this is very simple. We define with a define statement, and in this case, we are using 2 modules. So we specify these 2 dependency modules, and we take them as an argument here in the callback function. And then we are basically adding a class, a CSS class to the node. So we're basically changing the background. Okay. All right, now this is the user. This is the usage of those 2 modules. So let's take a look at that code. So here, base URL is JS. So so base URL is JS, meaning this base URL will be concatenated with this. So if you see the directory structure, you can see we have a JS. And then we have this my modules directory. Underneath we have a my module.js file, right? So that's the way we specify this base URL, and then the location is after this base URL. So it's going to be JS/my modules directory, and this module is JS/your modules directory. Okay, and this is the name of the modules, and this is the main part. Okay, and now you are going to use those two custom modules. So here you specify name and main, and name and main, and then you are going to call methods of those modules. So we are actually using set text from my module, and restore text from, again, my module, and change background from your module. Okay, so let's run this application. We'll call install, Maven install. Okay, and then we're gonna run it. So basically, we are going to have the greeting, and then we are going to replace that greeting message with hello dojo. Okay, and then we are gonna call set time method, timeout method, meaning in 3 seconds it will actually restore the text to greeting, and then it will actually call the background to greeting. So what we are going to see is, okay, so you're gonna click this one. So it got changed to, yeah, so it's restored, and then background is changed. So let me run it again. So initially it's hello, and then it changed back to it used to be hello, and then it changed hello dojo, and then it's changed back to original text of hello, and then background is changed. Okay, so we use the two modules, and one module has a set text and restore text method, and the other one has set background method. Okay, so hopefully that is actually relatively straightforward, creating your modules and using those custom modules. Okay, so moving forward, object-oriented programming support via declare, mix-in, and extend. So Dojo declare is this. We have seen example of Dojo declare last time. When we are actually creating custom widget on Saturday, right? So Dojo declare is basically used to simulate Java class system. Okay, JavaScript doesn't have a class system with a built-in inheritance like a Java, but Dojo declare kind of simulates it, so you can actually create your own class, basic class. Well, these are all object, but we are using the term class in a more generic fashion. So this is the name of your new class, and then this is your superclass that you are actually inheriting. So you're basically taking the properties of this superclass for your child class, and then you can also specify property map, which will be mixed in. So this is an example. So in this case, we are creating my.dinger new class, and the second parameter in this case is null, which means we don't have any parent. Okay, so we are basically creating a new class without a parent. And then you can have a constructor property, and this constructor property will be called first whenever new object is created from this new class. Okay, and inside the constructor, you're gonna call save mix in. Basically what it does is it's going to mix in the object of this with argument that is being passed. Okay, so we'll take a look at the mixed in a few minutes. Basically mixed in is mixing the properties of two objects. Okay, so you declare your my.dinger class. So once you have done with this, my.dinger class is created, and then you are going to call new my.thinger, and then you provide a set of arguments, and then what you got is basically instance of this my.thinger type. Okay, and then you can actually take a look at the count value. It should actually display 100. Okay. Okay, so this is the case that you are using dojo.declare, creating a class, inheriting from a parent class. So parent class in this case is my.thinger, which we just created. And then you are creating my other thinger. So basically you are creating my other thinger from my.thinger. So this is a parent class, and this is a class that you are creating. Okay, so here divisor property is included, meaning my other thinger has this divisor property, and it does have its own constructor as well. Okay, by the way, just like a Java constructor, whenever you're creating an object, in this case I'm creating my other thinger object, right? So the constructor of my thinger gets invoked first, and then constructor of my other thinger, in this case this constructor, gets invoked next, just like Java. Okay. Alright, so in this case, basically my other thinger, I'm actually passing count 50, and so the when you create an object of my other thinger has two properties. One is divisor, the other one is also count, and it should also have properties from my thinger as well. So my thinger has a property of the count. Okay. Oh, I'm sorry, this is not, yeah, so it doesn't have any property at this point. This is actually something that you actually, passing when you create the my thinger object. Okay, so in this case, this my other thinger has two properties. One is divisor, the other one is count. Okay. Okay, so mixin is a simple utility function for mixing object instances. Okay, so mixin combines two objects from right to left, overriding the leftmost object, returning the newly mixed object for use. So basically, it will use the right side object. It take all the properties of the right side object and mix in with the properties of the left side object. Okay, and it will return newly mixed object. Dojo mixin is very similar to Dojo extend, but only works on objects, whereas extend explicitly extends Dojo prototype. So we're gonna actually take a look at extend in the following slide. So mixin is only for object. Extend is extending prototype. So once you call extend, any new object will actually inherit anything from the extended the object. Okay. So mixin is just for object, between the object, and this one is actually by extending prototype, all the newly created object will actually inherit things. Okay, so let's see an example of Dojo mixin. So suppose I have a JavaScript object A, okay, assigned to variable A. So JavaScript object that I have has two properties, B and D. So the value of B property is C, and value of D property is set to E. Now, I am mixing another object, D and G, which has a D and G properties. But you can see we have this D is set to E, and this is actually the same property, right? So in this case, the F will override this E. Okay, once you mixed in. Okay. B and G, because they are not the same, they will be actually maintaining the values they have. So now, this Dojo mixin will actually set this, it will actually return object of A. So that is actually return object A. And if you actually see A, you are going to see three properties, B, C, BD, and G. Okay, which has a value of C and F. Okay, it will override a value of E, right? And then G has value of H. Okay, so again, mixing is working with object instances. We actually mix in these two objects. Okay, all right. Let's see. Moving forward. Dojo extend, on the other hand, works like Dojo mixin, but works directly on object prototype. So you're mixing to the prototype of the object, okay? So basically, after you do Dojo extend, any new object that gets created from it will be actually, having the things that have been extended. Okay, so let's see example of that. So here, let's say, in this case, we are actually extending existing widget called digit.title pane. Okay, so you can actually extend existing JavaScript object, and of course existing the widget as well. So in this case, we are extending this the digit title pane with this new property called random attribute. Okay, so what you do here is that you are actually adding this random attribute property to the prototype field of this digit pane. Okay. Right. So basically, when you are actually using this Dojo type, is creating this object, right? So that object is going to have this random attribute with this value. Okay. All right. Okay. So let's do that second exercise. So object-oriented programming. So let's actually run the application first, and then we'll actually go through different examples. Okay, so let's try with Dojo declare without the parent, and then Dojo declare with a parent. So here, let's try to run this without the parent, and let's press F12 so that we can see what's going on. So here we have count from my thinger object is 100. So let's see the code. So we are looking at without the parent case. Oops, I want to actually see the code. So we declare my.thinger class, meaning we are creating my.thinger class without a parent, okay? And it does have a constructor, okay? And then we create an object instance from my.thinger class, okay? Passing count property. So this, the thing should have count property now, okay? And so when we are displaying the value of this count from this thing object, it should actually display 100, right? Okay, so that is what we have seen. Yeah, 100. Okay. Now let's take a look at the case that we are creating a class from a parent class. Okay, so let's run this code. Just go back. Okay, so we are looking at this guy. So let's press F12. Now we are, if you see, it's basically calling. So let's see the code first, and then we'll actually get back to this. Okay. So in this case, let's take a look at the code. Okay. I'm actually looking at the with a parent. Oh yeah, with a parent. Oh yeah, so that is the right code. Yeah, so in this case, we created our mythinger. So this is exactly the same code that we have seen in previous example. And then we created thing1, which contains count 100. Okay, so it should actually display 100. So this is example that we have seen already. Now we are creating my.otherThinger class from this parent class. Okay. and this my other thinger has a divisor property of 5, and it does have its own constructor, okay, taking arguments, and it's displaying other thinger constructor is called. So we actually have console.log for constructor of my thinger and my other thinger, okay, and then here in constructor method we are dividing the count value with a divisor value. Okay, now we created my other thinger object, so we have a thing2 which is passing count 50. Okay, so you know the when this is invoked, okay, what happens is that we are creating my other thinger object, but so the constructor of method will be called, but before the constructor of this my other thinger gets called, it will call the constructor of my thinger first, right? This guy. So that's the reason if you actually see, so thinger constructor is called, and yeah, so this is the when creating the thinger object. Now these three, this is the three method, three log messages when my thinger, my other thinger object created the next. So you know basically what we're talking about is this. So when this my other thinger object gets created, now we are actually seeing the constructor method of the thinger parent class gets called first, and then other thinger constructor gets called next, and then you can also see it's a dividing 50 by 5 because we now have this count is 50 that is being passed, okay, and the divisor is 5, so it's going to be 50 by divided by 5. The result is going to be 10. Okay. All right. So it's actually relatively straightforward, hopefully. Okay. Moving forward. Now let's see the mixin. So again, this is an example that we have seen in the slide. Okay. So let's run this code. And you can see a.d is f, and then we can see this bdf, you know, bdg property contains cfg. Okay, so let's see the code, and then we'll get back to this one more time. So mixin is this one. So again, this is what we have seen in the code. So we have two JavaScript object. One is b and d. One has the B and D properties, which is set to C and E, and again we are mixing another JavaScript object, which has a D and G with F and H value to A. Okay, so it will return A, but also you know it's actually setting A with this as well. So when we actually see the D property of A JavaScript object, it should actually return F. Okay. And then when we actually inspect that JavaScript object of A, it should have B, D, and G properties with C and F and H values. Okay, all right. That is mixin. Now let's move on to. So this is you know the what we have seen. Okay. All right, moving forward. Let's see. Extend. So this two example, one is using Dojo 1.6 API, and the other one is using Dojo 1.7 AMD API. Okay, so let's see this example. So let's take a look at the F12. Oops. Yeah, so it's just displaying new values. So let's see the code. Okay, so here we are using Dojo 1.6 API programming style. So we require digit title pane, and then when DOM is ready, then we are using extend. Okay. So here basically what we are doing is that we are extending title pane, the title pane's prototype. So we're actually extending the prototype. So the prototype now should contain random attribute and say something method. I mean, say something property. These two properties are in fact added to the prototype of this title pane. Okay. So any object that gets created from this title pane should have these two properties. Okay. So, in this case, when you're using data dojo type, basically it's creating an object of this. Okay. So what that means is that it's going to now have this random attribute and say something. So when I actually get the reference of my widget by using digit by ID, this object should have these two properties: random attribute and say something. Okay, and so if I actually call say something, then it should actually display this random attribute value, which is new value. Okay, if I create another object like a var y, again, and then I should be able to call y say something as well, because any object that I get, I created from this widget should have these two properties, because I extend it by extending the prototype. Okay, so hopefully that is clear. Okay, so that is 1.6 model. 1.7 is working pretty much the same, so let's actually run it first. So again, it's displaying new value. Okay, so if I click this code, so we're actually using lang.extend, okay, instead of dojo.extend, but it works pretty much the same. So again, we have the same the random attribute and say something properties are added to any object that gets created from title pane. Okay, and so when I actually do say something, it should actually display new value as well. Okay, so that is extend. Now the last example is compare mixin with the extend versus mixin. Again, the difference between mixin and extend is that mixin is between the two objects and extend is for extending the prototype. Okay, so let's take a look at, let's run this. So basically, it displays this information. Okay, so let's see the code. So here we are. We basically have the my class function object, and then we are setting the prototype with this. Okay, so when we are actually seeing the when you actually display the prototype of my class object, then it should just display this. Okay, so that's what you're seeing here. Okay, and then we're actually extending the class. So here we are extending my class with this new property called extended property with this value. So any object that gets created from my class should have this new property. Okay. So now if I actually display the prototype, now we should actually see this. Okay. So that is now you're seeing modified with a language extend and this property, this one. Okay. And then we create a new object, and so now we are using mix-in. So again, mix-in will actually mix in an object. Okay, so it's not really extending a class, but it's actually mixing the object. Okay, so we have my class, and now we're actually trying to see T. We actually see the property of this one, not in prototype, but in the property itself. Okay. So we are going to see, instance. Okay, so you're actually seeing the property in the instance object rather than prototype. Okay. All right. So again, the difference between extend versus mixin is the mixin is working on object instance level, and extend is working on the prototype level. Okay. So basically, by extending prototype, you are basically extending class. Okay, so that is object-oriented programming APIs. Let's move on to HTML5 support in Dojo. So HTML5 data, there are several HTML5 compatible the features in Dojo, and starting from Dojo 1.6. So all the data attributes are now in the form of HTML5 data attribute syntax. Okay. So, the reason is because it validates with HTML5 validators, and again from 1.6 is a preferred style because, we want to actually kind of be compliant with the HTML5. Okay, so, we have seen examples of data Dojo config attribute instead of Dojo config. Okay, so this is old style and this is a new style, and this data Dojo config is HTML5 compliant attribute. Okay. And for any widgets, you're actually using data Dojo and something. Okay, again, basically every attribute in Dojo 1.6 and forward is actually in data something and data something. So even the event handler is going to be in the form of data Dojo event. Okay, so basically from Dojo 1.6. The names of all these attributes are changed so that they are compatible with HTML5 data attributes. Okay, another HTML5 related change is Dojo Object Store APIs. So those Object Store APIs are based on HTML5 index DB Object Store APIs. And basically, it actually provides a simplified APIs regardless of what store you are going to use. Okay, so these are, the HTML5 index DB object store API. The reason, the HTML5 contains this store API is developed to facilitate loosely coupled development where different widgets and user interfaces could interact with the data from a variety of sources in consistent manner. The thing is, in old days, Dojo has its own APIs for accessing some data, and Yahoo has its own API for accessing the data, and different JavaScript library has their own APIs for accessing the data. So, the idea of HTML5 is that now all these JavaScript libraries want to be using standard APIs for, accessing this data. Okay, so they actually all conforming to HTML5 store APIs. Okay, so HTML5, Object Store APIs really simplifies the construction and use of data stores in the first place, and besides, it's actually providing unified APIs. Okay, so those are Object Store based on HTML5 store APIs can work on any different type of implementations. For example, in-memory store, JSON REST store, or legacy Dojo data store, or you can also have a store wrappers that provide additional functionality. Okay, so basically, if you want to actually access some kind of legacy data store, maybe you have a mainframe, the data maintained in mainframe COBOL application, and you might in fact expose it as a Dojo data store so that your Dojo code can access them. Again, having the portability of the code in a sense. Okay, so these are the APIs. So it looks a little bit like Java. So store get is providing an index, and this is the query operation. Okay, so it's like a JPA or the criteria APIs of the Hibernate and JPA. So you provide that object that you want to actually query against. Okay, so basically what you're saying is that I want to query the store and I want to actually get all the entries that has a name property value with 1. Okay. You can also specify a function. So this function is basically saying that I want to get all the entries from the store whose ID is greater than 1. Okay. Put is you're actually putting an entry to the store. So here I'm actually adding an ID of 3, and the property I'm actually passing is name and 3. And here I'm removing that entry from the store. So you can see these APIs are relatively straightforward. Again, these same APIs could be used regardless of what concrete store implementation you're using. Okay, so same API could be used against the simple in-memory store or JSON REST store or legacy data store and things like that. Okay, so moving forward, so let's take a look at Dojo Store Memory. So Memory Store provides the full read and write capabilities for memory data. Again, it's very simple to use, just provide an array of objects. And Memory Store is also a synchronous store, which also simplifies the usage. So let's see examples of that. So let's talk about JSON REST and then we'll take a look at the hands-on lab. So JSON REST is that suppose if you have a data on the server, you can actually expose that data store, through JSON. Through REST APIs. Okay, so basically JSON REST providing the store APIs for for accessing through the RESTful based programming model. Okay, so let's take a look at the last exercise. So object store. So I have examples only for memory. I'm actually working on the JSON REST. I have to actually build the Spring MVC, Spring RESTful applications that could be actually accessed from the Dojo. Something I have not actually finished, so hopefully I should be able to finish some point. All right, so let's run this code. Okay, so these are both store memory examples. So let me run this guy. So basically, it's going to display the value of 1, 1, and 3, and 2. So let's see the code. So the code is relatively straightforward. Okay, so we have some in-memory data. Okay, in the form of array. So ID 1 and the name property, the value is 1, name property value 2, and we have a third whose ID is 3, and then the name property value is 1. Okay, so we created Dojo Store Memory object passing this data. Okay, so you're basically providing your array object to the data property. Now you got the Dojo Store Memory object called the store. Now we are performing some data store API operations. So here I'm trying to get the first ID of 1. So here when I actually try to display the name, it should actually display 1. This guy, okay, because I'm actually using this ID value. And here I'm actually performing a query operation. By the way, whenever you perform query operation, it will return array object. Okay. Entries that have been found. So it's like, result set of JDBC, so to speak. So here what you're saying is that I like to get all the entries whose name property value equals 1. So we should actually have a 2, this one and this one. Okay. So now I'm going to display the first item's ID, and that's 1. And then I'm displaying the second. In the array. So that's the reason we're actually displaying 1 and 3. Oops, not this one. Yeah, this one. 1 and 3. And then we are also performing query operation. This time we are passing a function object, and function object basically specifying I want to actually get all the object whose ID is greater than 1. Okay. So we should have these two, right? Okay, and so when I actually try to get the name of the first one, then you should actually display 2. Okay, so that's what we are saying here. Okay, let's see, and then we can put another one. So in this case, I'm replacing third with 3, and then I'm deleting this 3. Okay, so simplified APIs. The next one is pretty much a similar example. So this one, it has Mike, John, department is accounting, and things like that. So let's take a look at that code. So we have this employees array object, which has a name and department properties, and then we created data store memory object with data, and then I specify ID property. So this name property is functioning as an ID. Okay, and so I'm performing a query operation. So basically what I'm saying is that I'd like to get all the items whose department value is sales. Okay, so these two, and then I'm chaining for each. Okay, so one of the great thing of jQuery is that you can actually chain a lot of other functions, a lot of other methods to the result. So here, for the result of performing this query operation, so we have two items, and then we are calling for each, and you're basically displaying employee names. So we should actually display Mike and John, right? And that's what we're actually seeing right here, Mike and John. And then we added another new employee. So the new employee's name is George, and department is accounting. And then we removed Bill. Okay, so Bill is, we removed the second this item, Bill engineering. And then we retrieve object with the name Jim. Okay, so we have the Jim. And then we are displaying Jim's department. So Jim's department is accounting, right? Okay. So that should be that's this accounting. Jim's department is accounting. Okay. And then we are so this is actually retrieving an array. So we're basically, displaying all the gyms basically. And then we update this department, his department, and then we actually, store the change. Okay. Let's see. Oh, I'm sorry. Yeah. So this is not actually multiple gyms. It's actually, gyms properties. It's displaying properties of gym, meaning it will display the value of name and department. Okay, and then we update this department, and then so we change the department property with the engineering, and then we store the change. Okay, so that is pretty much what I have. So let's actually see questions. Two questions from leader: how to use Dojo or jQuery JSF 2.0. So you can use Dojo and jQuery, for that matter, any JavaScript code in your index.jsp page or index.html page, just like we have using in HTML page. Okay, so you can use JavaScript code or Dojo or jQuery with any web application framework. The next question: the PDF on JavaPassion.com isn't the same as PDF you are using in the webinar. It is missing a few pages and code samples. Yeah, so I'm gonna actually upload a new version. Okay. After this webinar. Any other questions?